So, you know Python lists, right? They're great, as long as you care about the order of things. But what if you don't? What if you need to grab some data using a name, not its number, in a line? Well, that's exactly where Python's super powerful solution comes into play, the dictionary. So, let's get right into it. So, here's what we're going to cover. First, we'll talk about why numbered lists just don't always cut it. Then, we'll meet the hero of the day, the dictionary. We'll look at how to pull data out of them without breaking things, how to build them as you go, and finally, we'll get into the really cool stuff, nesting them to handle some seriously complex data.
Okay, first up, why isn't a plain old list always the answer? Well, it really just comes down to one thing, how you look stuff up.
Okay, think about it like this. A list is kind of like a numbered lineup of people. If you want to find someone, you got to know their exact spot in the line, right? Number 5, number 10, whatever. But what if you had a phone book instead? You don't flip to page 50, you look up a name to get the phone number. That's exactly what a dictionary does for you in Python. It lets you find things by name, not by number. And this right here just lays it all out perfectly. On the left, with a list, you're stuck with that number-based question. Hey, what's it indexed to? But look at the right side, the dictionary. Now we can use a meaningful key, like the name Kieran, to ask a much more human question. What's the value associated with Kieran? See the difference? So much more intuitive.
Okay, so we've seen the problem. Let's talk about the solution. What is a Python dictionary really?
So, the core idea, the absolute heart of every dictionary, is something called a key-value pair. It's a really simple concept, but it's super powerful. You've got a unique key, think of it like a label or a tag, maybe a word or a number, and you pair that key with a value, which is just, well, it's the data you actually want to store. And making one? Super easy. You just use these curly braces. Inside, you set up your key-value pairs. You put the key, then a colon, then the value. So in this example here, the number 1 is our key, and it points to the name Naveen. But check this out. We go from key 2 straight to key 4. We just skipped 3 entirely. And that's the whole point. The order, the sequence, none of that matters anymore.
All right, so we know how to put data in. Now, how do we get it back out? And maybe more importantly, how do we do it safely, without our whole program blowing up?
This is where we hit a classic programming trap. So remember our dictionary? It has keys for 1, 2, and 4. What do you think is going to happen if we ask it for the data at key number 3, a key that just isn't there? Well, the first thing you'd probably try is using square brackets, right? Just like you do with a list. So you'd write data 3. But we already know that key doesn't exist. So what happens? And crash. You get a key error. The program just stops dead in its tracks. This is basically Python screaming at you, hey, I looked everywhere and I can't find the key you asked for. Now, in a real app, this is a total disaster. But don't worry, there is a much, much safer way. Instead of those risky square brackets, we can use the .get method. When you use .get, if it can't find the key, it doesn't crash. It'll just give you back none. Or, and this is really cool, you can give it a default value, like not found. It's the professional, non-crashy way to get your data. Okay, one of the best things about dictionaries is that they are not static. They're not set in stone. They are incredibly flexible. You can build them, change them, and add to them whenever you want. So let's imagine a common situation. You've got 2 lists. One has a bunch of names, and the other has their favorite programming languages. How do you merge these together into one neat dictionary, where the name is the key and the language is the value? Well, Python has this absolutely brilliant, almost magical way to do this in one line. You use the zip function. It works just like a zipper on a jacket. It takes one item from the first list, one from the second, and zips them together into a pair. Then you just wrap that whole thing in the dict function, and boom, it turns all those pairs into a perfect dictionary. So clean, so simple. And changing a dictionary later on, it's just as easy. Want to add a new person? Just assign a value to a new key, like data for Monica equals C#. It just works. Want to remove someone? Just use the del keyword with the key you want to delete. That's it. It's really that straightforward. Okay, now we get to the really powerful part, the secret sauce. A dictionary's value can be anything. It can be a number, a string, or it can be another list, or even another dictionary. This is called nesting, and this is how you start to model really complex real-world information. Take a look at this. This is where things get fun. The key Python points to a value that's just a simple list, no big deal. But look at the key Java. Its value is an entirely new dictionary tucked right inside the main one. This lets you build these incredible, rich data structures that can actually represent complex relationships.
So, how do you get stuff out of a structure like this? It's actually pretty logical. You just chain your requests together. First, you ask for prog Python. That gives you back the whole list, PyCharm, Sublime. Okay, now that you have a list, you can just use a normal list index on it, like 1, to pull out that second item, Sublime.
And it works the exact same way for the nested dictionary. First, progs Java gets you that inner dictionary. Then you just chain on another key lookup, square brackets, Java EE, to dive one level deeper and grab that final value, Eclipse. You can just keep chaining these together to go as deep as you need.
All right, let's do a quick recap. What are the big takeaways? First, dictionaries are all about key-value pairs, letting you look things up by name, not by a number. Second, please use .getting for safe access so your code doesn't crash. Third, remember they're super flexible. You can build and change them whenever you want. And finally, nesting is your secret weapon for handling really complex data.
So there you have it. You've seen how to go from a simple name lookup all the way to building these complex nested data structures. Honestly, this completely changes how you can think about organizing information in your code. So the only real question left is, what cool stuff are you going to build with this now?